here because the battery's dead, but then the charger ain't working, so I'm going to test the plug. So I went to go touch this. Look at how hot this wire is here. That's the plug for the block heater. So right there, that tells me, okay, that thing's drawing a lot. And then and you come over and look at the thing. Look at how hot that is. Thermostat's pooched, stuck on, reading 180 degrees. This thing hasn't run in over a week probably, so I'm gonna need a new block heater. Yep. Yeah, look at that. That's how your coolant level, 200 degrees on the block. Not even open. That radiator top hose, everything's hot. The thing ain't even running. So I'll do an autopsy on this after. I'm sure he's gonna want me to replace that too. But yeah, no good. No good. All right, so we got a failed block heater here. But it's not failed in the traditional sense. Like it stopped working. This one won't stop working. So basically when I came here for a separate issue, but noticed when I was checking the power for the battery charger that I just replaced, the block heater cord was hot as hell. And so then I looked at the temperature and it was like not even running. This thing hadn't run in a while because the battery's been dead. And I noticed that it was like 200 degrees. So I hit it with the thermal camera. Whole top of the engine, radiator hose, means the thermostat's opened up. So yeah, block heater's stuck on. Plus it's an 1800 watt, so I'm just gonna walk you through the process for replacing it real quick. So all right, replacing it's pretty straightforward. I like to leave it all together. Just loosen these. Just a jam nut on the bottom. Not a jam nut, just a nut. Take that off. Use them when you can. I try to just stay with everything that's here. It's just easier. You get to deal with drilling holes and stuff, you know. So this is how I do it. 10 millimeter on that. I think it's a 3/8 on the bottom. No, it's a 10 on the bottom. This is newer stuff, so. But yeah, so I'll just take this and just kind of muscle it out of the way here, if I could. There we go. Sometimes you gotta take this off. Threaded holes. I'm just trying to move that enough to get this out of the way, basically. I like to just have the new one mounted, basically, and ready to just stick the thing in, so you're not really messing with the coolant quite yet. So we'll grab the new one. Let me go over here. All right, so here's the new one. We're going to go with 120 volt, 1500 watts, plenty. I don't know why that had a 1800 watt. 1800 watts, 20 amp circuit, and the way you can tell is this plug right here. This will be the neutral side. It's flipped at an angle like that. And that's a 20 amp outlet. That's why that little dick is there. That means that's a 20 amp outlet. If you don't have this, that means it's a 15 amp outlet. And that's so you can't plug a 20 amp appliance into a 15 amp outlet. So when you're buying outlets, don't buy a 20 amp outlet and put it on a 15 amp circuit, because, you know, that's how these things end up burnt. So, but anyway, we're putting the 1500 watt on there, which is a 15 amp one. So it actually pulls about 11 amps. Basically just going to drop it. Same footprint, everything. Now these, you can change the clocking on these block heaters. So, you know, we're going to put it back in the way it was. This is facing that way. You can actually change the direction of this by undoing this bolt. And you can take this off and change it if you needed this pointed off to the side, off at an angle. You can change it any direction you need. It's kind of a pain in the ass to put it back together because there's a little gasket in here that likes to fall out of place, but that's the design. That's what it's made to do. So anyway, all right, so like I said, I'm going to just put it back in the same footprint. pretty straightforward. I'm basically just going to be putting it back in the way I took it out. When you can move these brackets around like this, it's really convenient. I really like working on these coilers. It's so easy. They do a pretty good job with them. Probably one of my favorite generators. I'll fast forward through this and cut it out. You don't need to see that. Pretty straightforward. What you want to do is you want to have as less time as possible reefing these things. I like to make it so you can move it. Of course, it's not going to cooperate, so I'll have to get a socket on the bottom, but that one's holding. Nice. So, put that in place. Now I'm going to show you the process for taking these off, which is pretty straightforward. Get out of the way here. I'm going to have a little spillage, but not too bad. Alright, a couple different ways. I use the pinch-off pliers, so you don't have to drain the whole thing down. Grab this stuff on here. Grab me this. I don't need that anymore. This was when I was doing the battery earlier. It's 1/2 inch. These are pretty useful to have in your tool bag. The 5/16 is actually on my little thing there. We're done with that. So we'll grab the 10. Put that on here. So we got this, that, and that. These are the pinch-offs. And that's going to enable me to disconnect these hoses without creating a friggin' mess. There's no isolation valves on here, as you can see. So, here, these should make a mess. It's inevitable. You're going to make some messes. There, and in there. Alright, remember we said that we wanted to reef this thing down a little bit more, so yeah, this is a nice design. I like it a lot. I'm gonna miss Kohler. Hopefully they don't change much, or Elco. Alright, so I use the snap-on ones. I mean, honestly, to be honest, the ones that Harbor Freight, those little ones you screw on, they're literally better. I just like these. I like these a little bit better. Durability-wise, I do break these, especially in the winter, but the snap-on guy just swaps them out for me. I just like them because they're just easier to carry, and you just reef them down, and then it's got this little thumb latch like that. You never want to do this when it's plugged in. You always want to make sure it's unplugged. So, hopefully that's a 10. Of course not. But you know what it is? It's a 5/16. So let's get it. All right. So we got the 5/16, the hose clamp, and basically all I'm going to do is be taking this off. And then one thing we're going to do, we got enough extra hose, so we don't have any issues. These are good. I mean, really good. I mean, they don't feel tough or hard or anything. I'm just going to leave them. So, we're going to have a little spillage here. I like to just get this right out of the way. I like using the ratchet better than the nut driver. It just fits in here better, you know. So basically, when I take this out now, it'll be a little messy. It's going to be residual in here because this thing's full of coolant. So let's see what the coolant looks like. Oh, nice. So what you're seeing there, that's all from the element inside the block heater, basically. But So we'll let that drain out in there. And then basically all I do is I'll take this now, cut this used piece off. These are really useful. You just swap these out with the regular utility blade razors. And then all I do is right on the new one. Whoop! And then right back on. Make sure it's seated. Kind of feel around there for that little, it's got that little burr right here. You just want it right under there, like that. And then you're going to repeat for the other side. Alright, so when you go to take the other side off, you're going to be introducing some air, so this thing's really going to probably belch out at you. Oh, I think it's kind of loose, actually. I don't know what's up with that. Yeah. Get it nice and loose so I can work that clamp around. Okay, I'm going to do that. Same kind of thing we did over there. Now when I take this off, just going to work it back and forth. Sometimes you need to get the channel locks involved. It might be alright, we'll see. There we go. There's the old one. Okay, take care of that. Same kind of thing with this. You might want to reuse these because you can't get them to seat right most of the time, especially if you're using silicone. So, whoop, nice and straight, clean cut. Let's get all this mess out of here now. I'm dumping that right in the grass when no one's looking. No, I'm just kidding. So I'm going to just put this in here now. I'm going to just feel around under there. That little burr. That little burr right here is what you're looking for. Right here in the end has this little burr. You want to feel for that. So you want to just make sure that it's nice and seated just behind that little burr. And then also, because as you're tightening, this thing's slowly rotating like that, so you want to just be mindful of that, and you want to kind of counter. So we're going to put it up a little bit higher, so when you tighten it, it'll go down into the position that you want it when you're done. So for the guy behind you, you don't need a friggin' crank on it too hard. You just want to feel that it's on there nice and secure, which I think it is. Take this off, take that off, put those aside. You can hear it going in there. Check for leaks, obviously. Let's tighten this back down. And that's it. That's how you change out a block heater. Just going to bleed the air out of it here in a minute. So I'm just tightening this. Alright. Quick little clean up here. Leave my rag. Take that with me. Let's take this with me. Out of the way. I like to put my tools right away because, you know what, you leave them and then you lose them. And that's friggin' annoying and expensive. So this is basically just the old box. The box from the new one. So I'll clean this off real quick. Yeah. I'm not going to plug it in just yet because I want to give it a little time to drain. Alright, these back. No, these aren't like $16 or whatever. It's alright. Usually gonna have a hard time finding them. That thing's old as hell. Alright, so back over here. Get the pig mat out of here. I'm gonna clean up all this mess that's in here. these kind of remnants of old leaks, you want to get them the hell cleaned up, because then you don't know what's old and what's new, you know. So I'm a big proponent of, you know, cleaning up the old stuff. Because I like a clean slate, personally. I don't like all this stuff on here like this. Like I said, it's hard to tell what's new and what's old when you leave it all dirty. So I'll pick all that up after. But, alright, check for leaks. I usually I'll run my hand down there around the bottom here. I don't feel anything. Alright. Okay. Alright. So I'm ready to go here. We're not going to plug it in just yet. I'm going to get up here and see what we got for a level on the coolant. I'm kind of open this and maybe help it along with the draining situation. I like to put a rag over this just in case, because this is hot as hell. Just keeps it in case it sprays, doesn't get you in the eyes. A little pressure. I don't know. I'll probably write this thing up for a flush, man. I don't like the looks of that at all. So now, I mean, it's full of coolant, I think. Man, that's hot as fuck still. It's full of coolant. I'll just take this and plug her in. Then you should start here on this thing. You want to feel this hose and make sure you can actually feel like movement on here. Any leakage. You want to make sure you get everything nice and clean. That way, if anything's leaking, it's really easy to tell. And this is like quality hose right here, this heater hose. You know, a lot of people like the silicone, and it's good. I do like it too, but I honestly prefer this stuff. You gotta change it a little bit more frequently, but it's really good quality hose. It doesn't leak as much. The silicone's a little sloppy with the leak, and you get these special clamps and shit on it. You can feel it chugging through. So what it is you got the hot side here. You got the hot going to the engine. It warms it up, forces the cold down. It eventually comes down here where the heated water, there's a thermostat internally that will make this shut off. And it needs to drop another 20 degrees before it'll turn back on. You'll see if you take the thermostat out of there, and I'll show you after when I do the autopsy on the other one. You'll see where it says like a certain number, like 100 minus 20. That means it'll shut off at 100 and it'll turn back on it once it falls 20 degrees. So it'll turn on at 80. So it's just another way to get the air out of the system too. This is really hot. So it shouldn't be too bad. All right, just a quick top off here. It's a little low. I'd rather it I use these simple green bottles just for this reason, because I don't have a lot of room here, so you can get them in these tight spots here. Alright, so you just heard that shut off? Alright, perfect. So it's working. Hot as hell, warm as hell, off. So that's awesome. Alright, yeah, we're totally filled up now. That in there. There we go. Good. Give it a little test bump here and kind of see where we're at. Getting ready to run it. Just want to get everything off here so it doesn't fall. Alright. Got the breaker off because I'm not sure what's going to happen in there. I don't want it to like transfer or anything, so I just want to run this thing, shut it off, and we'll go down and look at it, and we'll see. I'll talk to the guy and we'll see about taking her for a test rip. All right, quick little side note on something, fellas. We got this Kinsley sticker up here. Obviously, they're not going with him anymore, so don't want them to lose their service info. Not that anyone probably pays attention to it anyway, but I'll just take like one of these battery stickers here. I'll just cut off the battery part. They don't lose their service info. Jeez. This one needs to hit up the sharpening, the honing stone, I think. Yeah. And just right over it. See ya. Nice doing business with ya. There we go. Just like that. Alright, got the radiator cap on. Time for a test bump. Alright, that's it, basically. Alright, going to be doing a quick autopsy on this block heater that we took out earlier to kind of figure out what was wrong with it. I mean, I kind of suspect I know what's wrong with it, seeing it was keeping the temperature of the generator up to like friggin' 200 degrees and not shutting off, so that basically tells me that the thermostat was stuck closed. So, and it was warming, so we know the coil's good, obviously. We can verify that by just going across the neutral and the hot. There we go, 8.5 ohms. That's gonna obviously be a good coil. It was definitely working. The issue with it wouldn't stop working, so that's why I attribute it to a thermostat issue. So I'm going to take it apart and kind of show you how these things work real quick. So pretty simple, because I was explaining in the video about like reclocking them. They have this little screw right here where you can actually just take this screw out. Now say, you know, you got the thing mounted, but say you needed this inlet port to be facing this way. So what you do is you just take that screw out, you unscrew it, you literally take it out, you switch it to whatever way you basically need it to clock. Like this. Alright, and then you would just put that screw back in here and that would hold it in place, and then there you go. Now you change the way it clocked. So do that at any you know, any variation here. If you needed it over here, you know, whatever the case may be. I mean, every situation's different, but I mean, if you needed it like that, you could literally put it like that. The rub here is this O-ring, right? Typically what I'll do is I'll put a little sill glide in here to keep it in place, but once you take this thing out, man, it's kind of can be a bear to kind of get it back in. This one seems pretty decent. If you end up with a coolant system that had oil in it or something, sometimes this thing will swell up, and once it pops out, it will not fit back into place. So just to give you an idea. So I'll put it back together. So taking it apart to kind of see what's wrong with it. Go ahead and open it up. There's a screw here in the middle. And that's, well, I would have liked to have shown you the thermostat, but it just blew apart. But basically you can kind of see that's what the problem was all along the thermostat. So these things are pretty modular. You can basically fix anything in them, thermostat included. If I wanted to fix the thermostat, I very well could have. I could have just taken this apart, lift these tabs up here, and just slide. I like to slide it out of its little recess, see? And then the thermostat is actually, it's got this little metal keeper if this thing wasn't blown apart. I find these in the block heaters in the trash, and so I'll pick them out and I'll take them apart and I'll pull these out of them, and I keep them in a little container up in my toolbox over there. Because sometimes it's just easier to just swap the thermostat out. Like if I don't feel like dealing with the lines or the coolant hoses, just flip this thing out real quick, put the wires back the way they were, and that's it. But I mean, yeah, clearly that was the issue. But yeah, that's what happens with them, man. They get stuck on and they overheat, and look at, you can kind of see right here how that happens. 1800 watts I think is just too much for that size unit. But yeah, that was absolutely the issue. But again, if you were to check the coil, you would just take this apart, you'd isolate the wires so there's nothing connected, and you just go right here, boop and boop. So we got that same reading again like we had before. So that's how you know the coil's good. If it wasn't good, that's what you'd be looking at right there. That would mean that the coil was open. So that does happen. But I saved stuff like this. This is that little retainer. I'll throw that, add that up to my collection. And that seems chintzy compared to how they used to be. But yeah, I mean, all these are basically modular. The wiring harnesses, you can order the whole new, you can order these whole new harnesses if you wanted to. So you got just this. Sometimes these wires burn up, and you can replace just take the, you can't really hook it up wrong. This is the ground. It's a different size than the other ones, and all you're really doing with the thermostat is switching the hot. The neutral goes to one side of the coil, the hot goes to one side of the coil, and the other side to the other side of the thermostat, because the thermostat switches the hot on and off. So that's basically how they work. If I wanted to, I could literally make this thing work again by just putting a new thermostat in it and putting this back on, and it would work just fine. Because that coil does, I mean, it looks pretty healthy. It doesn't really look like there's anything wrong with it. I don't see any kind of corrosion on it or anything like that. So you can even order just this if you wanted to. So yeah, they're all modular. Like I said, you can clock these for any orientation you want. Very easy. Nice little units, man. Alright, I wanted to just kind of follow up on that, on the thermostat that we were talking about in the video, right? Common failure point. This is like my little stash of thermostats that I've mined out of failed heaters that I found in the trash and whatnot. But yeah, I take these little wires with them when you can, because that's a common failure point too, you know? So these are always useful. Sometimes this thing's just burnt. That's literally the problem. You know, these things are too loose in here. Gives you a loose connection, and loose connections are hot connections. Like, look at this thing's blown out like a prom date, you know? So no good. But anyway, back to the thermostat. I was telling you about this number that they have on them right here. Hopefully you can see that. I'm not sure. I'll shine a little light on it for you. But it basically says the L120 minus 20F. And what that 120 means, that's basically the temperature at which this thermostat is going to open and inhibit the flow of AC power on the hot side to the heater coil. So it's going to shut the heater off, basically. What it needs to close is at minus 20, right? So then it's going to fall 20 degrees down to 100 degrees, and basically this will close and allow that hot side to go to the coil, and the heater will work, so on and so forth. This is placed inside the heater on that inlet side, where the water flow goes back to the heater. And that's why it's very important that you plumb the heater properly. If you're plumbing it so it's heating the thermostat housing of the engine, basically what's going to happen is it's going to cause that thermostat of the engine to open. And now instead of like warming the block, now you're warming the radiator, now you're trying to warm everything. And what's going to happen is it's going to cause this thing to stay on like way longer than it's designed to. And that's what leads to them burning up, you know, ultimately, is because they just stay on way longer than they should. And that's what causes the issue. So I wanted to demonstrate here is kind of how they work, right? So I'll just show you here on continuity mode so you can hear the beep. I'm typically not a fan of continuity mode, but these types of things, it just helps. So what I'm going to do is I'm going to show you on this heater, or on this thermostat rather, so much for the anti-tangle leads. I'm going to kind of just show you. Now right now what you're seeing is it's closed, right? So power would be going to the heater. So that means that it must be under 100 degrees. So it's basically calling, right? So it's doing what it's supposed to right now. Now what we'd do is we'd test it out to make sure it works. You just heat it up. And once it gets to the 120, it should open. And you should hear that beep and go away. That'll give us, you know, an open basically. So that 0 ohms of resistance will turn to a OL. So I'll just give it a little blast with the torch here. And you saw that it opened, right? So still connected. It just opened because it reached its 120 degree threshold. Now it needs to fall 20 before it'll close again. So I'll blow on it. Watch. You can hear it too. Listen. You can put it on something cold, you know, like a can of Coke or something like this. It's not as cold as I'd like, but you'll hear a click closed. See, now it's calling for heat because it cooled down to under the 100 degrees. So that would be a good thermostat. In the instance with the one that we were just looking at, this thing was just totally smoked and it was just closed all the time. So it was allowing the heater to stay on and run continuously and never shut off. So basically the only thing that would shut that thing off is either the power failed or you know, the wiring failed to a point where it wasn't able to carry the current anymore. Yeah, so I mean that typically comes in the form of melted wires or something like that, or an issue with the outlet. But yeah, so that's just a quick rundown of how they work and stuff, so you kind of get an understanding of what's going on with them.